These are the divisibility rules, and you're probably familiar with a few of the simple ones, but you can demonstrate the divisibility rules pretty easily just by counting by whatever the divisibility test is. For instance, by twos, the rule is simply if it's an even number, it's divisible by 2. So if you count by twos, you'll see that you only come to even numbers, divisible by 2. So count by twos, 2, 4, 6, 8, 10, 12. You can see I'm only creating even numbers as I count by twos. Matter of fact, the definition of an even number is a number that is a multiple of 2. So as you count by twos, you're always having even numbers. So if I had a large number like 1086, of all the other things that it might be divisible by, I can be sure that it's divisible by 2. Now, the next one is the divisibility test for 3, and the test is about the sum of the digits. And by the sum of the digits, we mean this. I'll count by threes up to 30 and then pick it up from there. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42, 45, 48, 51, 54, 57, etc., etc. Pretty soon I'd be up to 84 and 87 and 90 and 93, and pretty soon I'd be up to 102, and pretty soon I'd be up to 120 and 123, and pretty soon I'd be up to 132 and 135. And if you just count by threes, there's something unique that you'll notice. The sum of the digits mean just look at the two digits. Don't read the place value. Just 3 plus 3 is 6. This has a sum of digits 6. This has a sum of digits 9. This has a sum of digits 12. This has a sum of digits 6. 4 plus 5 is 9. 4 plus 8 is 12. 5 plus 1 is 6. 5 plus 4 is 9. 5 plus 4 is 12. So you'd recognize that every time that I add the digits together in the number, I get a number that is divisible by 3. So the rule for 3 is that the sum of the digits is divisible by 3. So look at the number 135. 5 plus 3 is 8. 8 plus 1 is 9. The sum of the digits is 9. Because 9 is a count by 3 number, I should be able to divide 135 by 3. 4 times 3 is 12. Leaves a 1. Down comes the 5. 5 times 3 is 15. Sure enough, 45 times 3 makes 135. Here's a particularly tricky number under 187. 8 plus 7 is 15. Because 15 is a count by 3 number, I know that 87 would be divisible by 3. So 2 times 3 is 6. Leaves a 2, bring down a 7. 9 times 3 is 27. No remainder. 3 times 29 is 87. You ought to be able to remember that. 29 is a 20 and a 9. 3 20s is a 60. 3 9s is a 27. 60 and 27 is the 87 I had there. There is a divisibility test for 4, but it's not included in your questions test, but it is sometimes handy to know. The divisibility test for 4 simply says, if the last two digits are divisible by 4, then the entire number is divisible by 4. So, question, was 1992 a leap year? Every 4 years we have leap years, and they're always, the last two digits of the date will be a count by 4 number. So was 1992 a count by 4 number? Well, I don't want to go all the way from 0, 4, 8, 12, 16, 20, all the way up to 1992. The only question would be to look at the 92. And if 92 is divisible by 4, then 1992 is also divisible by 4. And so that's not much help, because you'd still just have to test, is there a 4 times something that equals a 92? And that's the way I would perform it. So I know that 4 times 20 is 80, and 12 more from 80 to 92 should mean that 4 times 23 is 92. That's why it's so handy to be able to do a 1-digit by 2-digit multiplication, because I can test divisibility so quickly that way. So the divisibility test for 4 is that if the last two digits are divisible by 4, the whole number is divisible by 4. I never asked that question on a quiz, but you do need to know that there is a test for 4s. The test for 5 is easy to see if you just start counting by 5s, 5, 10, 15, 20, etc. And you'll notice that alternately the last digit is either a 0 or a 5. So anytime you see something that ends in 0 or 5, for instance 155, you can be sure that that's divisible by 5. A number like 2010 would definitely be divisible by 5. So 2 times 3 makes a 6. And because 2 times 3 makes a 6, that simply tells me that every count by 6 number is divisible by both 2 and 3. So 2 times 3 is 6. The next count by 6 number is a 12. And 12 is divisible by 2, and 12 is divisible by 3. So what about a number like 72? Well, yeah, because it's even, I know it's divisible by 2. And because 7 plus 2 is 9, I know it's divisible by 3. How about a number like 84? Certainly that's divisible by 6 because it's divisible by 2. It's an even number. 8 plus 4 is 12, so it's divisible by 3. So the test for divisibility by 6 is that it has to be even, and it has to be divisible by 3. And so I have to go back and perform the sum of digits test to see. So how about a number like 216? Is that divisible by 6? Well, it's even, so it passes that test. Is it divisible by 3? 6 plus 1 is 7. 7 plus 2 is 9. So the sum of digits 9 means it's divisible by 3 because 9 is a count by 3 number. After 6 comes 7, and I never test this one, but there is a test for divisibility by 7. And the test is an awkward test to perform. The test goes like this. Take the last digit of a number and double it. So 8 times 2 is 16. And then pretend that number isn't even there, and look what remains if you just scrubbed it off the page. Well, that looks like a 16. Now take the number that appears after you scrub out that last place and take away double that number right there. That used to be an 8. Double an 8 is a 16. Now, if the answer is a count by 7 number, then your original number is divisible by 7. And the count bys technically all begin at 0. If I'm counting by 7, then the first multiple of 7 is 7, but 0 is considered to be the 0 multiple of 7. So counting by 7s could look like this. Anytime I do that subtraction and get a 0, then that's a count by 7 number. So just to prove it, 168 divided by 7 is pretty easy. 2 times 7 is 14. Leaves a 28. 4 times 7 makes 28. So 24 times 7 is 168. If 168 is a count by 7 number, then that would mean that 175 is also a count by 7 number. So here's the divisibility for 7 test. Take this number and double it. 5 doubles to make a 10. Now just scrub that number off the page. Pretend it's not even there. And take 10 away from 17. That is, take the answer that you got by doubling the last digit away from what's left when you scrub that out. 17, take away 10, leaves 7. Is 7 a count by 7 number? Well, certainly it is. That means that my original 175 would be a count by 7 number. So I could prove it again just by simply dividing. 2 times 7 is 14. Leaves a 3. Down comes the 5. And 5 times 7 is 35. Well, if 175 is a count by 7 number, well, then 7 more would be 182. That should be a count by 7 number. So the same test, I'll take the last digit and double it. It becomes a 4. Now just scrub that digit off the page, pretend it's not even there, and take the answer I got by doubling the last digit, 4, away from what's left. 18 take away 4 is 14. Is 14 a count by 7 number? Yeah, that's 7 times 2. So the number I had was 182. That should be divisible by 7. So 2 times 7 again is 14, leaves a 4. 7 into 42 goes 6 times. Now, most elementary textbooks never teach the divisibility by 7, but you need to know that every number has a divisibility test. There's a divisibility by 8 test, but you're not required to know it. It's not a particularly easy test to use. For instance, let's take the number 1,848 and ask if that's divisible by 8. The test for 8s is if the last 3 digits are divisible by 8, then the entire number is divisible by 8. But now you have to be able to test, would 848 be divisible by 8? Yes or no? If it is, well then so is 1848. So for the test by 8, you're just about as well off to actually go ahead and perform the division and see if it works. Because if it doesn't leave a remainder, we'd say it is. So 2 times 8 is 16, leaves a 2. 3 times 8 is a 24, doesn't leave anything. Down comes the 8, and 8 goes into 8 one time. And then it did divide evenly, or divided without remainders, the correct way to say that. So 1848 is divisible by 8. You're not required on my test to know that test, but it's good to know. Finally, the divisibility by 9. There's an interesting pattern that shows up, and many of you know this. As you count by 9s, the sum of the digits, again, is always a count by 9 number. So if I were counting by 9s, 9, 18, 27, 36, 45, 54, etc., notice the sum of digits is always a 9. 1 plus 8 is 9. 2 plus 7 is 9. 3 plus 6 is 9. 4 plus 5 is 9. 5 plus 4 is 9, etc. So I always have a count by 9 number on the sum of digits. Even if I go beyond 90, which is 9 times 10, now it goes to 99, then 108, then 117, then 126, then 135, then 144, then 153, and then 162. And notice that I don't always get 9, but I always get a count by 9 number. 9 plus 9 is 18. That's a count by 9 number. This actually gives a sum of 9. 1 plus 1 plus 7 is a sum of 9. 6 plus 2 plus 1 is a sum of 9. 5 plus 3 is 8 plus 1 is 9, sum of 9. 4 plus 4 is 8 plus 1 is 9. 153 has a sum of 9. 162 has a sum of 9. So anytime the sum of digits is a count by 9 number, if the sum of the digits is divisible by 9, so is the number. The divisibility tests are extremely important on the 7th grade STAR test. You will be asked to reduce some very large fractions. And if you don't recognize the divisibility test, and if you don't know how to perform 2-digit multiplication quickly, you will find the 7th grade STAR test to be extremely difficult. But if you develop these skills, it's not particularly hard. There is a test for 10 and 11 and 12, etc. But generally, if you know the ones that are on my test, you'll be able to tear into a division problem with some degree of confidence.